Hi everyone, welcome to another tutorial video. In our today video, I will go over how to create these two maps, and the second part of the video, I will go over how to overlay a raster file in one of those maps. So it will be like a pretty good way to show the results from an experiment, or if you want to show a specific file or dataset. So let's get started. In our case, in this one, we are going to use Jupyter. We're going to use Python. So Jupyter Notebook. So the programming language will be Python. So let's start creating a Jupyter Notebook. So let's name the Jupyter Notebook as basemap. So the first thing that we're going to do, let me press escape and let's create a markdown cell. And over here, it will be location. So I'm going to import OS. I'm going to use the function chdir to specify the location of the file, which will be this. So let's run it. Okay, so now let's import the libraries. So let's create a markdown cell. Libraries. In here, we're going to import matplotlib, pyplot as plt, and the other one will be from mpl toolkits period basemap. We're going to import basemap. Okay, so I imported the libraries. If you have this problem that I'm showing you right now in the screen, so I recommend you to use these two commands to install the libraries. Okay, so let's create the plugins. So let me just create a new markdown cell. So create the base map. Create a base map. So what I'm gonna do first is I'm going to develop, or I'm gonna create a new figure, and the figure size will be 18 by 12. plt show. So right now what we are doing is just creating an empty figure, and now let's start inserting the map and the things that we want to show in the figure. So let's create the base map. Create the base map. So I'm going to use a variable called m. So I'm going to call the function the base map. And now, so we need to insert some parameters that specify the map that we are going to create. So in this case, the projection will be null. So this one is a common projection that you can use if you're using WGS84. So now we need to specify the lower and the upper latitude and longitude. So in order to do that, so let's type LLCR and rlat So it will be minus 60 degrees, and URCR CR and R lat, and the upper one will be 80. And we will need to do the same thing, but with the longitude. So I'm just going to copy and paste, and over here I'm going to press Ctrl, I'm going to click here and click here and learn, and the numbers will be minus 80, 180 and 180, and the resolution will be the other parameter that we need to specify the resolution. So we're gonna use the resolution will be C, and here is a figure that shows you which resolution. So C is crude, so it's the lowest resolution, but it is the less computational expensive. Take into account that basically give you the lowest resolution. Then you can use L, which stand by low, I intermediate, H high, and F full. Take into account that F and I and H, H and F are the ones that take a lot of time. So if I run the cell right now, you just can see like the figure that was created. Just this one, but you haven't put anything yet, so that's why you cannot see actually the figure. But Python it's trying to print the figure. So what we are going to do right now is start mapping the elements. So let's draw some elements. So first, let's type m period draw coastlines, coastlines So now you can see those are the coastlines. Now let's draw the countries. So period draw countries. So now you can see the countries, country divisions. Let's draw the states. So now you can see every single state for every single country. And last but not least, let's draw the shaded relief. So this one is basically provides you a visual representation of the terrain elevation through shading. And this one is, so shaded relief is technically the more complex to plot. So that's why it's taking a lot of time. So let's wait for it. So now you can see here, darker colors represent higher elevations. And as you can see over here. And so now what we need to do, it will be cool to draw the grid lines. So draw let's draw the grid lines. So we will need two kind of grid lines. It will be the parallel ones and the ones that are located in the meridians. So let's try with the parallels first. So what we are going to do is create like steps starting from minus 60 degrees all the way until 80. But we need to put 1 unit, so 81. And the step will be, so those lines will be located every 20 degrees. So now I can use a command and period draw parallel. So I need to pass the variable that contains all the numbers. And if I call the labels, so I need to specify where I need to put the labels, either in this axis, this one, or this one. So for this, left will be the first one, then the second one will be the top, the next one will be the right side, and the bottom will be the last one. So we will need to specify true. We will need we're going to put we're going to set the labels for the parallel in the left side, which is the latitude values. So, and the other one will be false. So false, I'm just going to copy and paste. It will be false here, and false here. So now if I run the cell, let's wait for it. Perfect. So now you can see the parallel lines, and you can see here that those lines are every 20 degrees. Okay, so we need to do the same thing for the longitude values. So let's use meridians range from minus 180 all the way to 180, but we need to add 1 unit and 20. So if I just copy and paste this variable over here, you can see like the steps. So okay, so here appears the range. But if I create like a 4 I in parallels, and I print the I in this case, so you can see that it basically contains minus 60, minus 40, 20, minus 20, and all the way to 80. Okay, so we need to do the same thing for the longitude values. Minus 180 to 181 to take into account 180 and every 20. And we need to actually use the same theme, but in this case will be meridians. Okay, here we need to just copy and paste the longitude values, which are stored in this variable. And here we are going to put the longitude values in the bottom, which will be the last value, so it will be true. Perfect. So you can see here the base map, the latitude and longitude values, and so we just created one map. So let's do the second one. So for the second one will be, instead of this shaded relief, so we're gonna use a topo, this one over here. The main difference between shaded relief and a topo is that a topo gives you not only the land elevation but also the underwater depth, so you can see clearly the elevation in the land. Higher elevation are the darker colors, as you can see, but also you can see in the oceans, in the water bodies, you can see the underwater depth. So that is the main difference. So that is for this video, everything for this video. So in our next video, I will go over how to use these two maps to overlay a raster file and show the results in a really good way.